looks like this. All right, so if we're solving this triangle here, and we know all the sides, that means we're solving for an angle. All right, so we need to solve for an angle. And which formula would allow us to solve for an angle if we only knew the 3 side lengths? Which formula? All right, so if we did sine law, right, we'd have like a side length here and a side length there. And then we'd have to know one angle though. Like if we just use these 4, we need to know 3 out of the 4. So that's the only issue with doing sine law. So if sine law, whenever you do these here, like if you did those 3, or you wanted one of those, you need to have 3 out of 4. And so which formula allows us to solve for an angle? When we only know side lengths. So I know this one's tricky. So the trick here is we only know side lengths. So the only things we know are this, 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 and these. Like we can fill in those. All right. So we're going to solve for a side by using this formula right here. All right. So the way that would work is we go like this, the cosine, and this could be, we don't have to solve for angle C. We could be solving for angle B. I've just written this equation to solve for angle C. All right, so I'm going to solve for angle C. So it's the 2 shorter sides squared. Or sorry, not the 2 shorter sides, but 2 other sides squared that aren't C. So it's going to be like this. So I got 6.1 squared plus 5.6 squared minus 6.4 squared. All divided by 2 times 6.1 times 5.6. Now, if you recall, our number that we should get should be between 0 and 1, right? Because cosine values, this is a ratio. This isn't the angle. Angle C is different from cos C. Cos C is a ratio. So I'm going to put in my calculator right now. I'm going to do the top line first. 6.1 squared plus 5.6 squared minus 6.4 squared equals 27.61 divided by, and I'll figure out what this is too, 2 times 6.1 times 5.6. Right, so cos C is equal to 27.61 divided by 68.32. And I get a number like this. And I'm rounding this just to 3 decimal places. So that is what cos C is equal to. But angle C, right, to find angle C, we have to do this kind of like the -1 thing on our calculators, right? So we want to find the inverse to find the angle. So when we do that, I'm going to round to the nearest degree of 66 degrees. So that means this is now 66 degrees. So I've solved and I've got one angle. So now that I'm in a situation where I have an angle, I can do my sine law if I want to, right? I can use, as long as I use the angle and side that I know, I need to have an angle and side that are paired together. If I have an angle and side that are paired together, I can do sine law. I just need one that's paired together, which I didn't have before. All right, so now that I have that, I can do sine law and I can solve for any other side. I'm going to solve for angle A. Now I'm rearranging this, and you're probably wondering, like, wait a minute, I thought sine A has to be on the bottom. Well, it turns out it doesn't, as long as we're consistent. It doesn't make a difference. So I'm going to put all the signs over top of the letter. So in this case here, sine A, I don't know, and I want to find angle A. But I have a value for A, which was 6.1. And now I have a value for C, angle C, which is 66. And I have side C, which is 6.4. And now I can around the bend, or I can do cross multiply like the different ones. So I'm going to do this. I'm going to do around the bend. And so I'll get a value for sine A, which again is going to be different than angle A. It's going to be a number between 0 and 1. So I'll do sine 66 divided by 6.4 times 6.1, because we divide before we conquer. And then I get 0.87, and I'm going to round off. So this is going to be a 1, even though it's a 0 on my calculator. All right. So that is what sine A is equal to. And then if I want to find angle A, I just take that same value, 0.871, and I get 61 degrees. All right. And then once I have angle A at 61 degrees, I can do the easy part to solve for angle B. Angle B, when you have two angles of a triangle, we just take 180 and we subtract the two angles that we know, 66, 61. And I can do that out my calculator because I'm lazy and I like to use the calculator. And it gives me 53 degrees. So angle B is equal to 53. And now I know all there is to know about that triangle. I know all the angles, I know all the side lengths. All right. Let's go to part 2, which is talking about something called distributions. And all right. So we're going to do something called distributions. And basically what that means is how is what we've just been talking about, the data, where the data falls relative to the mean, right? So you may have seen pictures before of curves or data. And if the data looks like this, let's say that that is a graph. Let's make a better graph here. When we talk about something that has a normal curve, it means the data kind of looks like this. And it's symmetrical. It's generally symmetrical, meaning there's like equal amounts of stuff on both sides, equal amounts of data on either side of the mean. And I'm going to show you some examples of what I'm talking about. So this could be like grades, if we were talking about the grades in our class, right? If we said the average grade was like 70%, right? And then most of the data would fall between like that 70%. Here's like this would be like 50%, 60%, and here we have 80, 90, and let's say that was like 100%. Which on my crappy graph would assume that somebody made over 100%, which is impossible. All right, so right, so this is like if we did grades, a grade distribution, and we would find that most people fall on that like within the 70% range. And we have kind of like most of the data is kind of like within the first couple tiers, right? All right, so all those shapes are called distributions. So I'm going to steal an example from the textbook that I never gave you. And we're going to imagine that we have a student in the class named Noah, and he records the heights of all the individuals that walk into a hockey arena over a period of 2 hours. So in real life, if you're standing in Welland at the hockey arena and someone is taking heights of everyone walking for 2 hours, you'd probably call the cops. But in this case here, we're going to keep going with it because it's just an example. All right. And we took a frequency, which is basically the number of people. And these heights are in centimeters. All right. So just to give you some perspective, I am 190 centimeters tall. So I would fit into this category here. So I'd be on the taller range, right? This is tall. And this is like shorter, short, basically. So we see the range of the heights here. All right. So if we were to graph this, if I made a graph to show this, right? And you could find this to be relatively true, but let's make a quick graph. I'm going to grab my little ruler here. All right, so the height is going to be our y-axis, or our height in centimeters. And I'll do the frequency down here. Or sorry, wrong. My frequency is going to be this one here. And this one is going to be my height. All right, so let's make this as clear as possible. So how many groups do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 groups. I wonder if I can double it up. Can I go like this? 1, 2, 3, 4. Well, I'm a little off, but that's okay. All right, and then my frequency goes up to 41. So let's go like this. Let's say perfect. And I'll put my heights in like this. So this was, I think, 100. Is 100 to 110? Yeah. All right, so we can see how the groups are right here. So I'm going to do this very quickly. So this goes to 5, This is a histogram, by the way, and I did not get you guys to do them this year because I just figured you got to cut something sometimes. So I cut these. So I'm making a histogram. And if you're wondering why I am not attaching all the bars beside each other, well, that exactly is what a histogram is. It's not quite slightly different from a bar graph, except all the bars do not touch. They're side by side, but not touching. So 4 was 25. And an unrelated note, I hope none of you are invested in Bitcoin because you probably would have lost a lot of money lately. Oh no, Cody. Sorry, bud. Maybe Dogecoin's going to do better, but I think Bitcoin, its days are numbered, unfortunately. Doesn't help when Elon Musk tanks it. But I think it's just the beginning. You think it's going to go back up? It might. It might. I just feel like if Tesla, which is a pretty forward-thinking company, says that they think it's environmentally unfriendly, I think a lot of other companies are going to follow suit, and they might just switch to a different crypto. But it's possible. I pay attention to these things, by the way, if you're ever curious. I definitely follow the stock markets and different things. It's kind of what something I do in my spare time. But I figure that some of you guys might be paying attention as well. Some of you might have been looking at Dogecoin and being like, come on, Dogecoin, make me a millionaire. And some of you, it might have worked. And for some of you, you might have just gotten screwed and lost a lot of money. But because I have some friends that I think did. And I'm just filling this out. So you'll see that I'm trying to follow the values here. So 23, for example, corresponds to right here. I didn't see Elon Musk on SNL, but I heard it wasn't that bad. I don't really like him that much. There was a time when I did, but then he started opening his mouth and I stopped liking him. Um, and 8 here. And the last one is 2. So, all right. So this is kind of like, so we can see this is 41, 34, 23, 14, 8, 2. All right, so we can see that same kind of curve that I was talking to you about. This idea that there's like this kind of a curve that looks like this. And basically, a lot of data follows this curve. This is called a normal curve. This is what a normal distribution looks like, where the data falls on either side fairly equally, right? So if this is about height, average height, or basically showing the height of people coming into the Welland hockey arena, and we could see that most people fall in group 6, which was this one right there. So most people were between that particular height, right? And we can say that maybe that kind of gives us an idea of average height. And if we did like the height of people, there would be a normal curve of where most people tend to fall between, right? So this kind of shows you the normal height. And we could do the mean, median, mode of this. And then we could calculate the standard deviation as well. And this particular case, though, shows us that we have most people falling in one particular area, right? And that's the normal distribution. Now, it doesn't always work out that way. We could get one that looks like this. And you'll notice that if we did the same idea here, let's go this 1, 2, 3, 4, 5, 6. and 1. And if we do the same idea here, and so this is heights again, and this is a soccer team, and we have frequencies of, let's just go like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in category 1, we're up to 4. You'll notice that I went 3 wide this time. In category 2, we have up to 8. And category 3 is just 3. And 4 was, so 4, and then 5 was 9. Okay, so this one's a big one. Goes all the way up to here. And the last one was 2. Now, if we look at this distribution, it is not normal, right? This distribution kind of follows a pattern that looks like this. If I were to kind of draw a curve, it kind of looks like a camel with 2 humps. And that is how we define a bimodal distribution, meaning there are 2 modes or 2 points where it's much higher than the rest. All right. So where on the histogram do we think the peewees are? What about the seniors, right? So if this was a senior girls soccer team, right? So again, we are recording the heights of peewee and senior girls soccer teams, and we could see which one is going to be the peewee and which one's going to be the seniors. Well, we would assume that the peewees would be in category 2, right? Or we can assume peewees are shorter. Right, so we can assume that these ones are going to be the peewees and that these are going to be the seniors. And if we just looked at the table, what mode would you have noticed? Well, probably the biggest one, but we noticed that there are 2 obvious categories that are much larger than the other 2. All right. So we have 2 categories that are much larger than the other 2. And I think just one more example. Yeah, there's one more example, and then we're gonna be done. Okay, so we already know how to do the mean, median, mode, and basically this one is like just the example that we see down below here, which is that it's skewed. So essentially when we can do a curve that pulls off to one side, like this, we can see how it's pulling. This data seems to be pulling like this, but you would think that this is skewed to the right, but it's skewed. It's because imagine someone is grabbing this and pulling it to the left. This is skewed left. Even though the big lump is over to the right, it's actually skewed to the left because someone has basically grabbed the normal distribution would normally have been like this. Like that, okay? But someone has basically pulled this line and pulled it to the left. So that's why it's skewed left. And then this one would be skewed to the right. Okay, we're going to leave that there. And I'm going to show you the assignment I'm going to post. And I haven't posted yet, but I'm going to post it today shortly, probably like the next 15 minutes or so. And I'm just asking you to find the standard deviation. So it's almost ready to go. So I have a data set that's right here. There's going to be the numbers. And I want you to give me the mode, median, and mean. And then I want you to find the standard deviation. So you're going to follow the same kind of pattern I showed you before. And I'll put some hints below it just to kind of remind you what to do. And yeah, and I'll put the formula at the bottom here just to help you put it in as well. So I want you to do this through practice. So that's going to be your assignment, is going to find the mean, median, mode, and range, and standard deviation. So 5 things. All right, got it. And once you do that, you probably never have to see it again, but I want you to do this one. Okay, so that is going to be it for today's lesson. This is going to be the assignment. I will post it in the next 15 minutes, and I'll try and get the videos up for today's lessons as well. And if anyone needs help, you can contact me. I am sitting here. I'm working with one student following this, but yeah,